Okay, so hopefully you can see the front slide now. In this video I'm going to be doing what it says on the screen, forming and solving quadratics, and we're going to be solving them by factorizing. So this is assigned as a bit of an extension for the ones that were comfortable with simply being given an equation, asking to factorize and solve it. And this is for those that want that push closer towards GCSE style questions already. And this is what you will commonly see. So I'm going to go through, I've got a couple examples and I might ask you to do some as well, but always just feel free to pause the video and have a go first. If you feel like you can read the question and think you're confident to have a go, you don't need me to walk you through it straight away. You can try, and if you get it wrong, then you come and listen to what I've done. So this is an 8-mark GCSE question, and this is a genuine GCSE question. So you can see these types of questions hold so many marks, and it is so important to be able to do. We've done forming equations, so I know you're confident with that. We've just looked at solving quadratics. All this does is blend them two skills together, so it's not actually anything completely brand new, and you actually could possibly be comfortable with this off the bat, and if you are, that's absolutely fantastic. But first, let's do part A. So first of all, we just want to show that x squared minus x minus 56 equals 0. When we get given a show that question, you don't ever want to use this in your working. You want that to be your final line of working, and that is it. If you use this in your working, you automatically will just get 0 marks because you've not shown that. You can't use something to show something. Think of English with a definition. If you're asked to define a word, you can't use that word to define itself. You've got to use other words to define it. In maths, when you're trying to show something, you've got to show other sorts of maths to show this line. So the area of the trapezium is 36, and we've got some algebraic lengths for our trapezium. So we want to find the area of this trapezium in terms of algebra. So the area of a trapezium, the formula for that is a plus b over 2 times by h, where this is a, this is b, and this is h. A and b are the parallel sides, so that could be a and that could be b. It doesn't really matter, just as long as it's the parallel sides, and then the height is obviously what the height is. So we need to do x plus 2 plus x plus 6 divided by 2, and then eventually times that by x minus 5. So let's go ahead and do this bit first. So I'm going to add the top line. That's going to be 2x plus 8. And then I'm just going to drop down and write everything I had before. You can obviously go to the side of the page and do these little bits of working if you don't want to do everything in a big drop down like I am. So 2x plus 8 divided by 2, well, do 2x divided by 2, and then do 8 divided by 2. Let me set this out nicely. And then we're going to times that by x minus 5. So hopefully you could remember your FOIL method for this. When I expand this, I'm going to get x squared plus 4x minus 5x minus 20, and I'm going to collect them terms. I'm going to get x squared minus x minus 20. So we can see already we've kind of got this bit of the equation, haven't we? So we're getting there. We're getting there. We now need to use this bit. Well, the area is told to be 36. Well, this is the area because we've just used the area of trapezium formula with the length they've given us in terms of x. And we also know 36 is the area. So they must equal each other because they're both the area. So then if I take 36 from both sides, I'm going to get, well, minus 20 take away 36 is minus 56. And can you see? I've got exactly the same thing. And when we've finished to show that question, you put a little box and colour it in. Or you can write QED. That's some Latin abbreviation for like I've done it. And that box means the same thing. So in this case, we've finished that part A, and we've got our 4 marks. The beauty of questions like this is if you get completely stuck on this one, well, you can actually just forget the top half of the question, and you can just go ahead and solve this and find a length for 4 marks. So you don't actually need to do the first part of the question because they've already told you what you should come out with. Anyway, let's go ahead and solve this. We're going to need to factorize to solve a quadratic. So let's think of what we can do to factorize this. Well, our factors are 56. I think it's going to be 7 and 8. Because I know 7 and 8 will help me make a -1 in some case. So I need a positive and a negative. That's the only way I'm going to get a negative 56. And I want a -1 once they add together. So I want my bigger number to be a negative. So therefore, x plus 7 equals to 0. So then x equals to -7. Or x minus 8 equals to 0. Therefore x equals 8. Got to make a decision here. Well, this does not make sense. We can't have a length of -7, can we? Because if we substitute this back in, -7 plus 2, that's -5. We cannot have a length of that, so we want to say x equals 8. And then you might want to write a bit of a sentence. X. So we say we can't have that, as we can't have a negative length. So we've just got one answer there. Hence, find the length of the shortest side of the trapezium. Well, in this case, 8 plus 2, that would be a length of 10. 8 minus 5 would be a length of 3. And 8 plus 6 would be a length of 14. So the shortest length is 3 centimetres. We know this diagonal wouldn't be the shortest length as well, because diagonals are always longer than the straight down. So that's 8 marks. I don't think it's too bad, especially once we get used to it. Okay. Alex is W years old. His sister Claudia is 3 years younger than Alex, so Claudia I can say is W minus 3. I'm going to write that as a colon actually, just to not get confused. So W minus 3. And the product of their ages, remember product means multiply, is 180. So if I do Alex times by Claudia, W times W minus 3, that's going to equal 180. I can expand this bracket. Well, to be fair, that's probably enough for A. We've made an equation because it's got an equal sign in it and it represents the information. Going ahead to try and solve this, well, we'd want to expand it. And then we'd want to make it equal to 0, so then we can factorize. So I've just taken 180 from that side. And now we want to factorize this, because that's going to allow us to solve this quadratic. So you can see these kind of follow a pattern. Set up your equation, make it equal to 0, factorize it, solve it. And it always does this, it always follows this pattern, so once you get used to it, it's just such a good skill to have to pick up marks. But anyway, let's have a think of this. Well, God, I might have to use my whole brain, and I'm going to go through it in the full method. So we can have 1 and 180, 2 and 90. We could have 3 and 60. Could 4 go into it? Yeah, 4 could. I don't think it's actually going to help us, but 4 and 45. 5, yeah. 5 and 36. Could we have 6? 6 and 30, I can see that one pretty easily. 7, no. 8, no. 9, yeah. 10, yeah. 12, I know 11's not going to go in. 12 and 15, okay, that one seems like that's going to make a -3. All of these are just I can tell from doing these questions a lot, and hopefully you can tell now, that they're not going to work for factorising. It's going to be the 12 and 15. It's probably one of the hardest factorisings you'll get. So we know 12 and 15 is going to go in there. We want a negative 180. So we know it's going to be positive and a negative in here. And we want this to be a minus 3. So my larger number must be negative, because when I do 12 minus 15, that's going to get me minus 3. So then when we go ahead and solve this, we're going to ask the question, well, w plus 12 equals to 0, so w equals to minus 12, and w minus 15 equals to 0, so w equals 15. Which one of these answers actually makes sense? Can you be minus 12 years old? No. So w equals 15, so Alex equals 15, because Alex is w. It's not always going to be the answer. They could have asked you for Claudia's age, and you'd have had to say Claudia's 12. And always write a sentence about that one. Can't have a negative age. It just has to be as simple as that. You've got to have a reason why you've crossed out a solution. Okay. Okay, I've got 2 more. So feel free if you want to have a go at this one and test yourself. A rectangular field is 10 centimeters longer than it is wide. So I would always label the smallest one as an x. Then if it's longer, that's going to be x plus 10. And the area of this field is 2000. So the area of this, in terms of algebra, we would just multiply these, wouldn't we? It's a rectangle. So x times by x plus 10, that's going to be x squared plus 10x. Well, that's going to be equal to the area of 2000. Because that's also the area, isn't it? That's the algebra area, that's the number area. They always equal each other. You might read this question and it doesn't really tell you to factorize and solve it, but it says to find the perimeter. Well, we're going to find what these lengths are by factorizing and solving. We're going to find what x is, and then we're going to use that to then find the perimeter. So this is a bit more difficult question because it doesn't particularly tell us exactly what to do, like it did on that first one, where it kind of walked us through it slowly. So I want to make it equal to 0. And then I want to factorize this. They are not being nice, are they, with these factorizations? So let's just go for it. We can skip out some of the obvious ones that aren't going to work. We're looking for some numbers that are pretty close to each other. Let me think to myself here. 50 and 40? Yeah, I think 50 and 40 would be the ones that work here. Obviously you can take a bit longer than me to figure that out. So, we want positive and a negative in there because that's the only way we're going to multiply to make negative 2000. And then we want it to be positive at the end of it once we've added them. So I think our larger number needs to be positive here. Then we're going to solve. X minus 40 equals to 0, so x equals to 40. And then x plus 50 equals to 0, so x equals minus 50. Again, which one makes sense? Not that one. We can't have a negative length. So x equals to 40. We are not done yet. Well, let's think. If x equals to 40, we've got a rectangle of 40 by 50, x and x plus 10. So the rectangle actually looks like this, and all the measurements are in meters. So the perimeter, this is the easy part, we just add the lengths, don't we? So 50, 100, 180 meters. So that final bit was the easy bit. And then final one. This is a bit of a tough one. So we've got to split the shape up. I would be tempted to split it like this. You could probably split it like that and get the exact same answer. I need to think, well, what's this length now? If that's x plus 3 and that's 2, well, this must be x plus 1, because if we did x plus 1 plus 2, we'd get to this. And that's the only bit of working out I actually need to do. So label up your bits of the shape, and let's find the area of A first. I'm going to find the area of both of these, and I'm going to add them together. I'm then going to make it equal to the number area they've got, which is 74, and then I'm going to solve, substitute it back in to find the perimeter. It's going to be a bit of a long one. You could just be asked to show that an equation is something and then to solve it as well. So the area of A is going to be x plus 2 all times by 2. That by that, which is 2x plus 4. The area of B is going to be x plus 1 times by x plus 5. We're going to get x squared plus 6x plus 5 at the end of that. So then the total area is going to be x squared, 6x plus 2x is 8x, 5 plus 4 is 9, and then we know that the area is 74, so that's going to equal 74. I want to take away 74 from both sides, so 9 take away 74, it's going to be minus 65. We want to then factorize this. So let's think of our factors of 65. Have a go at this up here. I'm not going to list the ones that are obviously going to be wrong, like 65 and 1. We could think, well, 5 and 13. Let's double check that that works. Let me do 5 times 13. Yep, that's 65. There's a difference of 8 between them, so I think that's going to work. We want one to be positive and one to be negative, because this is a negative 65. And we've got a positive in the middle, so when we add them, we want it to be positive, so my larger number should be positive. So let's then solve. X minus 5 equals 0, so x equals to 5, or x plus 13 equals to 0. You can probably already tell where I'm going with this, but you do have to write it out. You can't just be lazy and skip this step, you will lose marks. We can't have a negative length. So x equals to 5 is our length. So if we go for our shape again, instead of x, that's still going to be 2. Instead of x plus 3, that's going to be 8, because 5 plus 3. Instead of x plus 5, that is going to be 10. Instead of x plus 2, that is going to be 7. We still need to figure out these two lengths here. Well, if that's 7 and that's 10, that must be 3. And if that's 8 and that's 2, that must be 6. Because 2 plus 6 gives us to 8, and 7 plus 3 gives us to 10. So we have the beautiful job of just adding these together for our perimeter. So I'll just go around 15, 25, that's an unbound, makes up to 20, 26, and we're talking about centimetres. So there were some difficult questions there, some really hard factorising for sure, and some tough problem solving. There's going to be some questions for you that are similar to that, and they'll be directly taken from exams, so this is fantastic practice for you. Hopefully that was nice and helpful for you.